Hey guys, 7-7, inverse relations and functions. This all falls underneath the same learning objective to find the inverse of a relation or function. Um, and there are, I think, 6 examples here, so a lot on our plate. But a lot is pretty quick and easy, and so that's why there's so many, I guess. All right, first and foremost, let's review a little bit the when we're given the information about a function, the domain and range, remember we did the mapping, and it had to be 1 to 1, right? Each domain had to be unique. The range did not have to be, but the domain did. Okay, so when we take the inverse, do we just switch. The range becomes a domain, the domain becomes a range. So the inverse of R, the domain is now what the range was, 1 and 2, and your range is now the domain. Would the inverse be a function? No, it wouldn't, because for 1, there's 2. For 2, there's 2. So just because it is a relation does not mean it's a function. And just because one of them is a function doesn't mean that they both will be. I know. Are you confused yet? All right, let's go ahead and see what's going on with these examples. All right, skipping over this because it's pretty easy. A, find the inverse of relation M. So we're given relation M, and to find the inverse, and I hate stacking it horizontally, so I'm just going to go ahead and do a vertical stack. So X, Y. So now, instead of putting, hey, I'm just going to do it like this all together. We've got -1, 0, 1, 2. For -1, x is, or y is -2. For 0, it's -1, 1, -1, 2 is -2. Okay, so now my inverse is going to be -2, -1, -1, -2. There we go. And then my y values will be what I had down the x column in the last table. Okay, so there we go. We have the inverse of relation M. Now part B says to graph M and its inverse on the same graph. I'm trying to get, okay. Excuse me. The graph paper. If this takes too much longer, I'll pause it because I understand how boring this part is. Sorry about that. Okay, so now let's go ahead and graph these. And it said to do it on the same graph. So that way you can see both, what they both look like on this graph. Excuse me. Okay, so doing the original relation, we have -1, -2, so -1, scroll down just a little, -2, and then we have 0, -1, 1, -1, and 2, -2. All right, now graphing the inverse, we have -2, -1, we have -1, 0, we have -1, +1, and then we have -2, +2. If you were to take a line and go through the diagonal, the XY diagonal, you would see that the red is a mirror image of the black. Okay, pretty cool, huh? All right, example 2, interchanging X and Y. So we need to, in order to find the inverse, we switch y and x, just the variables, just the letters. We don't change the squaring or anything like that. So y equals x squared plus 3. To find the inverse, x equals y squared plus 3. Very, very, very easy. Hopefully something you guys will grasp quite quickly. So to find the inverse, first thing to do is switch variables. So x equals y squared minus 2. We need to solve it for y, so we're going to add 2 to both sides. And so now we have x plus 2 on the left equals y squared. To get rid of that square, we have to take the square root of both sides. That cancels out. Excuse me, and we have y equals the square root of x plus 2. And that is your answer. Pretty cool, huh? To kind of build onto the next equation, what can we not have underneath the radical in order for this to have a real solution? We can't have a negative. Good. All right, so we cannot have anything less than -2 underneath this radical in order for it to work, right? Let's take a look at example 3. Graphing a relation and its inverse. Fortunately, we've just done that. Isn't that cool? Okay, so graph y equals -x squared minus 2 and its inverse. So you have two options here. You can graph it and then reflect it, or where the textbook author is wanting you to go would be to graph this one and then interchange x and y to find your inverse. Whoops, that was way too messy to count for anything. Okay, so if we have x here and we have y here. So if I plug in -2, -1, 0, 1, 2. -2 gives me 4. -2 squared is 4. We have -4. So -4 minus 2, that's -6. -1. -1 squared is 1. -1 minus 2 is -3. 0. 0 is just 0. 0 minus 2, -2. Plug in 1. 1 squared is 1. -1 minus 2 is -3. 2 squared is 4. -4 minus 2 is -6. Okay, the inverse of that is going to be -6, -3, -2, -3, -6. Corresponding y values will be -2, -1, 0, 1, 2. Okay, so now let's go ahead and graph this. It'll be much easier graph coordinate grid this time. There we go. Okay, the red one. -6, 1, 2, 3, 4, 5, 6, and then down 2. And I want that in red. Okay, and then we have -3, -1, -2 and 0, -3, +1, and -6, +2. Okay, you can see that we have a sideways quadratic equation, right? Okay. Let's graph the blue one. We've got -2, -6, 2, 4, 6, -1, -3, 0, -2, 1, -3, 2, -6. All right, and it's opening down. Close enough, right? There you go. Okay. Example 4. Finding an inverse function. Okay, this one has a few more steps in it than everything else. So I'm going to go ahead and stop at this point just to prevent you from getting too bored. Okay, and then we'll finish this up in just a second.